Hi, Geometry Scholars. Here we are in Chapter 10, Lesson 3. We're going to talk about using chords today. So in order to meet our objective of using chords of circles to find lengths and arc measures, you'll have to recall the definitions of chord, arc, and diameter, which of course we will go over. So starting with chords of circles, we're going to have 4 theorems and 4 examples. Starting with, recall a chord is a segment with endpoints on a circle. There's only 2 ways this can happen. Because the endpoints lie on the circle, any chord divides the circle into 2 arcs. A diameter divides a circle into 2 semicircles. That's the first example here. So if it's right in the middle, then you've got 2 half circles. Any other chord divides a circle into a minor arc and a major arc, like the second picture. So here's our first theorem. 10.6. In the same circle, or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So chord arc AB is congruent to arc CD if and only if segment or chord AB is congruent to segment or chord CD. And in our class notes, I'll be like highlighting stuff like this. So I know that this one here is congruent to this one here, right? The arcs. If and only if it must happen that these 2 chords are also the same distance. Second theorem, 10.7. So we're going to talk about perpendicular chord bisectors. If a diameter of a circle is perpendicular to a chord, so that would be EG, then the diameter bisects the chord and its arc. So again, I'd be highlighting EG bisects, if EG is perpendicular, then EG bisects FD. So that makes FH congruent to HD, but it also bisects the arc. So FG arc is congruent to DG arc. And that's what it says. So, and that only happens if EG is a diameter. This one's a super handy theorem. You're going to want to learn that one right away, as well as the converse. If a chord of a circle is a perpendicular bisector of another chord, then the first chord is a diameter. So if you know this is a perpendicular bisector, then SQ has to be a diameter. Also very handy. Here's our first example.
In the diagram, circle T is congruent to circle Q. Segment FG is congruent to segment JK, and the measure of arc JK is equal to 80 degrees. Find the measure of arc FG. Solution. In the diagram, segment FG is a chord because its endpoints are on the circle, and segment JK is a chord because its endpoints are on the circle. Because segment FG and segment JK are congruent chords in congruent circles, the corresponding minor arcs, arc FG and arc JK, are congruent by the congruent corresponding chords theorem. So the measure of arc FG is equal to the measure of arc JK, and from the given information, this is equal to 80 degrees.
Very simple and straightforward. Second example, using a diameter.
Part A, find HK. Part B, find the measure of arc HK. Solution. Part A, locate segment HK in the diagram. Segment HK is a chord, and segment JL is a diameter of circle M. Notice diameter JL is perpendicular to segment HK. So by the perpendicular chord bisector theorem, segment JL bisects segment HK, and HN is equal to NK. So HK is equal to 2 times NK, and in the diagram, NK is equal to 7. So HK is equal to 2 times 7, which is equal to 14. Part B, locate arc HK in the diagram. Again, diameter JL is perpendicular to segment HK. So by the perpendicular chord bisector theorem, segment JL bisects arc HK, and the measure of arc HJ is equal to the measure of arc JK. By the perpendicular chord bisector theorem, write the equation the measure of arc HJ is equal to the measure of arc JK. Using the diagram, substitute 11x degrees for the measure of arc HJ and the quantity 70 plus x degrees for the measure of arc JK. Subtract x from each side of the equation, and 10x is equal to 70. Divide each side of the equation by 10, and x is equal to 7. So the measure of arc HJ is equal to the measure of arc JK, which equals the quantity 70 plus x degrees. Substitute 7 for x, and this is equal to the quantity 70 plus 7 degrees, which equals 77 degrees. And the measure of arc HK is equal to 2 times the measure of arc HJ. Because the measure of arc HJ is equal to 77 degrees, this is equal to 2 times 77 degrees, which equals 154 degrees.
This is another example where you have to be very careful about answering the question being asked, right? Because even though we solve for x, and then you solve for one arc, the question said, find HK. So make sure you are answering the question being asked. So a third example, since we had 3 theorems, is perpendicular bisectors.
3 bushes are arranged in a garden as shown. Where should you place a sprinkler so that it is the same distance from each bush? Solution. Step 1. Label the bushes A, B, and C as shown. Draw segments AB and BC. Step 2. Draw the perpendicular bisectors of segment AB and segment BC as shown. By the perpendicular chord bisector converse, these lie on diameters of the circle containing points A, B, and C. Step 3. Find the point where the perpendicular bisectors intersect. This is the center of the circle, which is equidistant from points A, B, and C, and it represents where you should place your sprinkler.
Now, I don't know that we're actually doing this because, again, during our pandemic, we haven't been doing constructions, and this may be a construction example, but intuitively it should make sense to you. This picture that you want to see where their diameters intersect. I do believe we have another example. These are examples we'll do together in class. Theorem, last theorem. 10.9. In the same circle or in congruent circles, 2 chords are congruent. So here we're talking about A, B, and C, D. 2 chords are congruent if and only if they are equidistant from the center. So what you'll notice is, and that's the perpendicular distance. So if EF, the perpendicular distance here, and EG, the perpendicular distance here, if EF and EG are equal, if they're equal in measure, then you can say that chord AB is congruent to chord CD, and vice versa. Chord AB is congruent to chord CD, if and only if those 2 little lengths there are the same. So, of course, we'll have an example with that. Here's how it works.
In the diagram, QR is equal to ST, which is equal to 16. CU is equal to 2x, and CV is equal to 5x minus 9. Find the radius of circle C. Solution. Because segment CQ is a segment whose endpoints are the center and a point on the circle, it is a radius of circle C. Because segment CU is perpendicular to segment QR, triangle QUC is a right triangle. Apply properties of chords to find the lengths of the legs of triangle QUC. Step 1. Find CU. Because segment QR and segment ST are congruent chords, segment QR and segment ST are equidistant from C by the equidistant chords theorem. So CU is equal to CV. By the equidistant chords theorem, CU is equal to CV. Substitute 2x for CU and 5x minus 9 for CV. And this gives you 2x is equal to 5x minus 9. Solve for x, and x is equal to 3. So CU is equal to 2x, and x is equal to 3. So this gives you 2 times 3, which equals 6. Step 2. Find QU. Notice segment WX is a diameter. Because diameter WX is perpendicular to segment QR, segment WX bisects segment QR by the perpendicular chord bisector theorem. So QU is equal to 1/2 QR, and QR is equal to 16, so this equals 1/2 times 16, which equals 8. Step 3. Find CQ. In triangle QUC, sides CU and QU are legs of the triangle, and side CQ is the hypotenuse. Because the lengths of the legs are CU equals 6 and QU equals 8, triangle QUC is a right triangle with a Pythagorean triple 6, 8, 10. So CQ is equal to 10. So the radius of circle C is 10 units.
And the thing about examples like this is they take everything into account and they can get very messy looking. So again, I'm going to encourage you to always use either highlighters or colored pencils to follow everything and go over it more than once. All these things can get confusing. This is the first time you've done circles this detailed. So definitely keep your notes right with you and use those hint buttons when you're doing your big ideas homework. Then, of course, monitoring, and it's time for our exercises. I think this assignment's only 15 problems because they get kind of involved.